Okay, so we've got a review of the properties of parallel lines. First of all, I want you to make these 2 marks on those 2 lines on your paper. They look like little additional arrowheads that are somewhere on the line. And really all they are is whenever you see this, this indicates that you've got a pair of parallel lines. Remember that our symbol for parallel looks like actually the number 11, but it's a pair of parallel lines itself. So a couple of the names and then the properties of these particular angles when you are given a pair of parallel lines cut by this line right here, which happens to be called a transversal. So given angle 1 and angle 5, angle 1 and angle 5 have a special name, and they are called corresponding angles. Now when lines, boy, I cannot write with this thing, corresponding angles. When you have 2 parallel lines, the relationship between those corresponding angles happens to be that the measure of angle 1 is equal to the measure of angle 5. So given a pair of parallel lines, corresponding angles are always congruent, and we can tell corresponding angles because they're angles that happen to be in the exact same spot in the group of 4, but in a different location. So if you notice, 1 is in the top left-hand corner of the group of 1, 2, 3, 4. 5 is in the top right-hand or left-hand corner of the group 5, 6, 7, 8. They're in the exact same spot, but in a different group. The other pair of angles we want to make sure we focus on happens to be angles 4 and angles 5. So angle 4 and angle 5 are called alternate interior angles. And I'm abbreviating here so I can run into this space here. So alternate interior angles are angles that are inside, and by inside that means that in between the 2 parallel lines, alternating because one is on one side of the transversal and the other is on the other side of the transversal. One of the relationships, or the relationship between alternate interior angles, happens to be that the measure of those angles are also equal. So the measure of angle 4 is equal to the measure of angle 5. Okay, next we'll look at angle 1 and angle 8. Angle 1 and angle 8 are called alternate exterior angles. Now again, they're alternating because they're on opposite sides of the transversal, and they're exterior because they happen to be outside, not in between the 2 parallel lines. They're on the outer edges of those. And the relationship between those two is the measure of angle 1, a nice way to write that as an 8, and the measure of angle 8 happen to be congruent to each other. So if you notice, most of these angles happen to be equal to each other. However, there are a few that differ. So our next one that we're going to look at is we're going to look at, let's say for example, angle 4 and angle 6. Angle 4 and angle 6 are called same side interior angles. So again, they're angles that are inside, so they're in between the parallel lines, and they're on the same side of the transversal. Now, just by eyeballing those 2 angles, you can see that those 2 angles cannot be equal to each other. Angle 6 is clearly acute, and angle 4 is clearly obtuse. The relationship that exists between those 2 happen to be that the measure of angle 4 plus the measure of angle 6 happens to equal 180 degrees. We're going to look at 2 more sets of angles, but these 2 sets of angles really actually have nothing to do with parallel lines themselves. So just for that sake of argument, I'm going to kind of ignore all of these angles that are down here, because I'm just going to look at the relationships that are existing between the angles that happen to be up on top. Now these relationships will still be there for these other angles. But again, you don't need parallel lines in order for this to exist. So, first one we've got angle 1 and angle 4. Angle 1 and angle 4, as well as angle 2 and angle 3, are vertical angles. And hopefully one of the things that you learned back in secondary 1 is the fact that the measure of angle 1 is always going to be equal to the measure of angle 4 because they are vertical angles. The other relationship that I want us to look at happens to be between 1 and 2. Angle 1 and angle 2 are side by side, so they are adjacent to each other, but they are considered to be a linear pair. So any angles that are side by side with each other and, better yet, create a straight line when they are side by side together are referred to as a linear pair, and the relationship between those two angles happens to be the fact that the measure of angle 1 plus the measure of angle 2 also equals 180 degrees, just like your same side interior angles.